sun rises, here's what the sun does. If you are on the equator, it goes straight up every day. But from day to day, the whole path shifts either to the left or to the right, depending on the time of year. And okay, on the equinoxes, there's only 2 days of the year when the sun rises due east and sets due west. It doesn't happen any other day of the year except on the equinoxes anywhere. But on the equinoxes only, it happens everywhere. It rises due east, directly east, and sets directly in the west, everywhere. Okay? And on no other day does it do that anywhere. It always rises and sets somewhere to the north or south. Okay, well, so let's say we're on the equator, and this is the equinox, one of the equinoxes. Let's say it's the spring equinox. Where do you think it comes up the next day, right after the equinox? You know, March 23rd or 24th or whatever. Is it going to? It's not going to come up due east. I just told you it only does that on the equinox. So where's it going to come up? If it's later than the spring equinox, that means we're moving into the northern hemisphere. What season? We're moving towards spring. Yeah, spring and into summer. Right? So it's hotter in the northern hemisphere, so the sun is getting farther. Which direction? It's hotter in the northern hemisphere, the sun's getting farther north. Right? That's why it's hotter here, because it's higher in the northern sky more of the day. Okay, so it would be moving that way, right? Because this way is north. If you're looking east, this way is north. You got to get this part straight, and that way is south. So the sun goes south for the winter. You ever heard it said that birds fly south for the winter? Well, the sun goes south for the winter, but comes north for our summer. So, okay, the day after the equinox is going to go up like that, like that, like that. You know what the only difference is here? It does the same thing, comes up due east on the equinox, but it comes up at an angle to the vertical equal to our latitude, which is 37 degrees or so, 38 degrees. So it's going to go up like that, which is exactly what the kind of thing you were saying. I mean, we'll get to sunsets in a minute. It's just like this, but kind of symmetrically opposite for sunsets. So what's it going to do the next day here? If it's on the spring equinox, March 21st or 20th or whatever. Which way is it going?
To the right.
To the right? Well, on the equator, if it's going to the left, it's just you take this whole pattern and you just tilt it by your latitude. Take this whole pattern and just tilt it by your latitude. Okay, so it's actually going to do this the next day, and then this the next day, and then this the next day. Finally, it comes up farthest around to the north on what day? One we're looking forward to about a month from now.
June, July.
Summer solstice. Summer solstice, June 21st. It'll come up, I'll draw it in red, hot. Comes up farthest north of east. Again, this is to the north. And then it turns around. In fact, you know what the name solstice means? Solstice, sun stands still. In other words, the point of rising goes like this. It kind of changes sort of fast from day to day near the equinoxes, but then, as with anything that turns around, it has to turn around, it comes to a stop. So the sun stops, the sunrise stops moving, and then it starts working its way back. And then after the fall equinox, it does the symmetrical thing in this direction. In fact, if I had a blue marker, I would show you where it comes up on the winter solstice. This is way south of east, and that way south. And so there's this whole solar window, and you just tilt that whole window based around the equinox points, the east and west points, for your latitude. If you're in the southern hemisphere, what does it do? You're going to need a black marker. Southern hemisphere, same pattern, only now tilted this way. The sun will be highest in the sky north. It'll be in the north. Remember, here, where's the sun highest in the sky every single day? Due south, remember? And in the southern hemisphere, it's highest in the north. So the paths will go like this, depending on your latitude. And guess what happens if you're on the poles? On the poles, again, it's tilted from the vertical equal to your latitude. Well, what if you're at the North Pole? What's your latitude? 90 degrees, right? 90 degrees north latitude. So 90 degrees from the vertical is what? This is a 90-degree angle, right? 90 degrees from the vertical we call what? Starts with an H-O-R-I, horizontal, right? So here's what the sun does. You ready for this? On the North Pole, on the equinox, it spends all day crawling around the horizon. Comes all the way around the horizon as it slowly rises. The next day, where's it going? It comes up, it's up a little tiny bit higher. Goes all the way around. Next day, a little bit higher. Finally, on the summer solstice, it's 23.5 degrees above the horizon. That has that to do with that tilt of our axis. So you're watching this one, it goes like this. It moves around the sky like this. So, you know, all those days in between. And it never gets higher than 23.5, and then it comes back. And then on the fall equinox, it's again going all the way around the horizon. And then for the next half year, it's below the horizon. It's dark, or twilight, for half a year. So that's the same solar window as this one, only you tilted it all the way down, where half of it's below the horizon. And for the equator, you tilt it all the way up. And for the southern hemisphere, you tilt it all, you know, and the south pole, it's going to be like that. Does that make sense? So I have a whole model of this that I built out of balsa wood. I was going to bring in and show it to you guys. Maybe I still will, and we can still get that on tape. But here's basically a picture of all of this. Well, first let me just make one more connection. If we connect the eastern sky for our latitude now, okay, here in San Jose, forget about the equator and the poles and all that, we've already done that. But hey, here in the northern hemisphere, San Jose, it comes up out of the east, heading south, right? Because where is it highest in the sky every single day? What direction? South. It's heading towards the south, gets up highest in the south. So let's take all these paths, and the sun, you know, during the course of the year, all on different days, it looks like a rainbow. I guess you could call it a sunbow. And hey, this is what you watched. Maybe you both watched sunsets. So now, you know, the places where the sun goes down are like this. And again, these are all tilted from the vertical at our latitude angle, which is
So that's looking at the west, right?
yeah, this is looking at the west, and on the equinox, you know, follow this path right here, comes up due east, goes down due west. And then, you know, during the time of the year when it's farther north, summertime, it's coming down way farther north of west, which is way over here. Here we are, the final point. That's not north, but it's north of it. It's that direction, north. North is to our right if we're looking to the west. But it goes down as far north and west as possible. And so see, it's farther in the sky for longer, right? It's in the sky for a lot longer because it has to go way up higher, which is what makes it so hot. Because near the peak of the day, it's in the south, but it's not very far from overhead. At this latitude, it's about 13.5 or 13 degrees from overhead. Not that much, so it's baking. It's baking us. Does that make sense? So you have this whole beautiful picture. And if you were to look at the sky, you know, from outside, check this out. Ready? Here's the horizon. Here's you. Here's you. There's me. There's Sri. Sri, Nia, Joe. Okay, there we are. Here's the sky. Okay, what's the sun do on the equinox? Now let's say we're looking east, so that's going to be the eastern horizon. This is going to be the western horizon. You know, if they were looking to the west, they'd be looking out the board. Okay, you get the picture? I've got a three-dimensional thing here. Okay, well, the sun goes up like this, goes down there on the equinox. That's the path of the sun. You see, it's like a sphere with a circle drawn on it, right? You understand that I'm foreshortening that due to it's an art problem here, okay?
Yeah.
Okay, well, what does it do the next day after the spring equinox? It comes up which way? To the left or to the right?
To the left.
To the left, yeah. So, you know, we'll do this, this. Eventually, on the summer solstice, it'll come up as far north of east as it ever does here. It won't quite get overhead, though, because why? We're not in the what? It's overhead only in the
Northern.
starts with T-R-O-P. Tropics. We're not in the tropics, so it's not going to get overhead. But it gets kind of close to overhead, so it does this. That's the overhead point there. And then it comes down over here. And then in the colder half of the year, which I'll try to mark it with a green marker, I guess. You know, west, because we were looking out of the board, we'd be seeing it, we'd be seeing this scene right here. Imagine these guys here looking out through this fence. To them, it looks tilted that way, right? Does that make sense? Isn't that cool? It's as simple as that. You have this solar window, and it's the same everywhere on Earth except for the tilt of it. And the swivel point, the axle, is the east and west points on the horizon. The whole thing tilts about that. And that's simply because as you move around the Earth, you're looking at the same scene in the sky of what the sun's doing, but as you move around the Earth, you're doing this. So you're looking at the same scene, but it's just tilted according to where you are on the Earth. You're here, and then now you're here, now you're here, so on. You're looking at the same thing. Does that make sense?
Yeah.
All right, well, that's one for the ages. So we've got it in the can now, on tape. So anyway, but I'm going to ask you some questions on the final that test your understanding of this concept. I'll say, hey, if these are 3 different dates, which one goes with which date, that kind of thing. Sunrise or sunset. So hopefully, once you get the picture, you can just answer any number of questions about it, So, okay. Well.